Hello students, today we are going to discuss the topic that is types of errors. Now before starting this topic, first of all, I had selected a group of 10 students and sent them to take a reading of an experiment for measuring the pressure. But before them, I will go and take the reading of that experiment in the most ideal condition, and I had get a reading of 40, that is known as true value. Now the first student goes and he will take a reading in the normal condition and he will get a reading as 38. Similarly, next student will get a reading of 39. Similarly, 41, 42, 43, 37 and so on. Now the reading taken by all the students is known as measured value. Now true value is never possible because ideal condition is not possible, so we will not be able to measure the true value for any experiment. Now what do you mean by true error? It is the difference between true value and the measured value of quantity. So if we will take the difference of true value and measured value, that is 40 minus 38, it will comes as 2. Similarly, 40 minus 39, it will comes as 1. Similarly, 40 minus 41, the difference is minus 1. Similarly, so on. Now that all readings is known as true errors. So it is the difference between the true value and the measured value of quantity. Practically, true error cannot be found because true value of a quantity cannot be measured exactly, because we cannot measure the true value, so we will never get the true error. Now the next one is the expected error. The maximum difference of measured value from the true value of a quantity is known as expected error. Now in all the differences, we will get the maximum difference as 40 minus 37, which will be equals to 3. So that will be the expected error. So the maximum difference of measured value from the true value of a quantity is known as expected error. Now what do you mean by discrepancy? It is the difference between the two measured values of the same quantity, that is 38 minus 39. Similarly, 39 minus 41 and so on. The difference between the two measured value of the same quantity is known as discrepancy. Now the next one is residual error. It is a difference between the most probable value of quantity and the measured value of quantity. It means that if we want to calculate the most probable value, then it will be the average of all the measured values. Suppose that for all these measured value, the average will comes as 41. So the difference between the most probable value and the measured value, that is 39. Similarly, 41 minus 38. Similarly, 41 minus 37. That all differences is known as residual error. Now how can we calculate the most probable value? It will be calculated by taking the average of all the measured values. Now the next type of error is mistakes. Now mistakes are errors which arises from inattention, inexperience, carelessness and poor judgment or confusion in the mind of the observer. Now mistakes can be happened by lack of attention, inexperience, carelessness, poor judgment, confusion in the mind of the observer. So it cannot be rectified because we cannot determine where we had done the mistakes. Now the next one is systematic error or cumulative error. Now it can be removed by applying a simple correction. So what do you mean by systematic error or cumulative error? A systematic error is an error that under the same condition will always be of the same size and sign. Now, under the same condition, the nature of the error is same. Systematic errors have the cumulative nature. Now, we will take an example. Suppose that if a tape is p centimeters short and is stretched n times, then the total error accumulated in the measurement of length will be n into p centimeter. Okay, students? Now, one note is there, that is, the systematic errors are very easy to remove because a general correction can be determined and applied for them. Suppose that a tape is p centimeters short. Now, during the first stretching, the tape is short by p centimeter. Now, in the next stretch from the starting, the tape is shortened by 2p centimeter. Similarly, after n stretching, the tape will be shortened by n into p centimeter. So, we can easily correct that value by applying a general correction of n into p centimeter. That is known as systematic error or cumulative error, which can be easily removed. Now, the next error is accidental error or compensating error. Now these errors occurs in different size and in different direction for each observation. Now if you will take a reading of a particular experiment, then suppose that if the true value given in the book is 30, so you will get the reading as 29.8, 29.5, 29.7, hardly you will get a reading of 27. Okay, so these error occurs in different size and in different direction for each observation. Accidental error follows law of probability, which is shown here. Now in this curve, the errors of small sizes will have very high frequency of occurrence, and the large size error, that is large size error, will have very less frequency of occurrence, which is shown here. That is, when the size of error is very small, the frequency of occurrence is very high. Now a note is written here, that is, the errors of small size occurs more frequently than errors of large size. We had already discussed it. And positive and negative errors of same magnitude, that is plus 0.1 error as well as minus 0.1 error, will have same probability or frequency of occurrence, which is shown here. Now if the magnitude of error is same, then its frequency is also same. Most probable value is the value of measurement which has the maximum chance of being the true value of quantity. It means that it is very close to the true value of the quantity, because we cannot measure the true value, so we have to measure the most probable value which is very close or which has the maximum chance of being the true value of the quantity. Now we want to calculate the most probable error. Now what do you mean by most probable error? It is the deviation of measured value from the true value which has the maximum chances to occur. Now if we want to compute the most probable error in a single observation, then it can be calculated by an empirical formula, that is ES is equals to plus minus 0.6745 under root summation V square upon n minus 1. Now in single observation the size of error is large, but when we distribute this error into number of observation, then the size of error will get reduced. Now we will calculate the most probable error in mean of a number of observation. Now we have to distribute this error into number of observation. So it will be represented by EM is equals to most probable error in single observation divided by root n. So we will get the formula as plus minus 0.6745 under root summation v square upon n into n minus 1, where ES is the most probable error in single observation, V is the difference between any single observation and the mean of the series. Similarly, EM is the most probable error of the mean and n is the number of observation on the series. Now the next one is sources of errors. Now the first one is manual source. Now the manual source is generally done by the human beings. So it can be defined as mishandling of instruments or mistake in reading or calculation by the observer. Second one is natural source of error. Error may also be due to variation in natural phenomena such as temperature change, humidity, gravity, wind, refraction and magnetic declination. Now, if the sources of error is natural, then the error will arise due to natural phenomena such as temperature changes, humidity, gravity, wind, refraction, etc. Now the next source of error is instrumental. Now it is due to the imperfection or faulty adjustment of the instruments which is used for the measurement. So generally if the instrument is faulty, then this type of error arises. Now that is all about the types of errors. Thank you very much, students.